Good morning, dear students. I hope you are all safe by staying at home. In last class we had seen about the periodic classification of elements. We had seen four classifications. First one is Dobrenius triads, and second one is Newland's actives and Mendeleev's periodic table, and fourth one is Henry Moseley's periodic table, that is called the modern periodic table. In this class we are going to discuss about Henry Moseley's periodic table, that is modern periodic table. First I want to recollect the features of modern periodic table. This already I taught, even though if I recollect the things, that will be easy for you for better understanding. So first we are going to see the features of modern periodic table. The modern periodic table is based on increasing order of atomic number, that is more fundamental property. So it is based on the increasing order of atomic number, that is more fundamental property, and the horizontal rows are called periods. There are 7 periods in the periodic table, and then the elements are placed in the based on the number of shells of atoms, and the vertical columns are called groups. There are 18 groups in the periodic table. So 7 periods, 18 groups in the periodic table, and the 18 groups are further classified into different category because of their different physical and chemical property. So based on physical and chemical property, the groups are further classified into these types. First group is called alkali metals, and second group is called alkaline earth metal, and 3 to 12 are called transition elements, and group 13 is called boron family, group 14 is called carbon family, group 15 is called nitrogen family, group 16 is called oxygen or chalcogen family, group 17 is called halogen family, group 18 is called rare gases. Now the periodic table is further classified into blocks. First you should know what is block. Already I taught about how the electrons are placed and how the protons and the neutrons, where the neutrons and the protons in the atom and where the electrons. Neutrons and protons are present at the center of the atom, that is called the nucleus, and electrons revolve around the nucleus in circular path, that is called the orbit or shells. And then the orbit or shells contains 3-dimensional space. This is like a street, this is like a home, this is a 3-dimensional space where the electrons are finding most of their time. So the orbit contains orbitals. Orbit contains orbitals. Orbitals are further classified into p orbital, s orbital, d orbital and f orbital. There are four different kinds of orbitals: s orbital, p orbital, d orbital and f orbitals. So according to that, the elements are according to the number of orbitals accommodated by the electrons of each element. The elements in the periodic table is further classified into 4 blocks. The first block is called the S block elements. S block elements includes group 1 and 2. That means this one, this is group 1, this is group 2, this is group 3, group 4, group 5, group 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. As I told you, the first group is called the alkali metals. Why it is called the alkali metals? This is otherwise called the representative elements also. Why it is called the alkali metals means, except hydrogen, remaining elements are capable of forming the alkali or base, alkaline solution or base. How it is forming alkaline or bases means, when it reacts with water, these elements, these metals, except hydrogen, all these elements are metals. Lithium, sodium, potassium, all these elements are metals. So these metals, when it react with the orange color elements, are called metals, alkali metals. Why it is called alkali metals means, when it reacts with water, it is capable of forming alkaline or bases, that is soapy to touch. The solution the solution formed because of the reaction between this element and water. This element, these metals with water, when it reacts with water, it forms base or alkaline, that is soapy to touch, that is capable of turning the vegetable dye will be converted as, from red to blue. This is capable of, this solution is capable of changing the vegetable dye from red to blue. And then group 2. Already I told S block elements contains group 1 and 2. Now we are going to see group 2. Group 2 elements, beryllium, magnesium, calcium, these are group 2 elements. This is called the alkaline earth metal. As I told you, group 1 is called the alkali metals. Why it is called alkali metal I explained there. Because this, when this metals reacts with water, they will be forming alkaline or basic solution, that is soapy to touch, that is capable of turning the vegetable dye from red to blue. So they are called alkali metals. Since they are forming alkaline or bases when it reacts with water, so they are called alkali metals. And group 2 are called alkaline earth metal. What is alkaline earth metal means? These metals, when they react with oxygen, when it reacts with oxygen, it is capable of forming oxides. These oxides are formerly called, earlier called, these oxides are earlier called earths. So they are capable of forming, when these metals reacts with oxygen, they are forming oxides. The oxides are earlier called earths, and when these oxides, when these metal oxides reacts with water, when they dissolve in water, again they will be forming alkaline or bases. This is also soapy touch solution. This is also capable of changing the red vegetable dye into blue color. So these are group 2 metals are called alkaline earth metal. Why it is called alkaline means the oxides of these metals, reacts with water, they will form alkaline or bases. So the bases turns vegetable dye from red to blue. And why it is called earth? Why the word comes here, earth here means when these metals reacts with oxygen, it forms oxides. The oxides are earlier called earths. So these group 2 elements are called alkaline earth metal. Group 2, this is group 2, these elements are called alkaline earth metal. First they will be react with oxygen, they form oxides. When these oxides dissolve in water, they will be forming alkaline or bases that will turn vegetable dye from red to blue. So they are called alkaline earth metals. And then the next one is called P block elements. Group 13 to 18. Group 13 to 18 are called P block elements. This block, next we are going to see P block elements. From group 13 to 18 are called P block elements. Group 13 to 18, here it is 13 to 18 are called P block elements. And group 13 is boron family, group 14 is carbon family, group 15 is nitrogen family, group 16 is oxygen family, group 17 is halogen family, group 18 is called rare gases or inert gases. Why it is called rare gases or inert gases means they will be found very little percentage in atmosphere, so they are called rare gases. Inert means they are not, they are a monatomic molecule. So they will not easily react with, already their electronic configuration is completely filled, so they will not react with any other element easily, so they are called inert gases because of their inertness. Inertness means inactivity. That means they will not easily react with any of the elements, so they are called inert gases. Since they are found very little percentage in the atmosphere, it is called rare gases. And from group 13 to 18 are called P block elements. Why the P block element is the home of a variety of elements? Why it is getting variety of elements means because of the electronic configuration, because of the atomic number, and then why it is a home of variety of elements means it contains metals, non-metals and metalloids. All the three types of elements are placed in the P block. This is a P block. This contains metal. These are the metals. These are non-metals. And these are metalloids. Metalloids also found in the P block elements. So it is a home of variety of elements. And then next we are going to see about D block elements. Group 3 to 12. Group 3 to 12 are called P block elements. Sorry, D block elements. Because this contains mostly metals. D block elements mostly contains metals, and why they are placed between left and right portion means their property. This group properties are intermediate between left portion and right portion, so they are placed at the center of the periodic table. So these are about D block elements. And then next we are going to see about F block elements. F block elements contains 14 elements in the lanthanum series and 14 elements in the actinide series. The elements which follow the lanthanum are called lactinides, and the elements which follow the actinum are called actinides. They have different property, entirely different property from those of the elements. So they are placed at the bottom of the periodic table. Because of their peculiar property, they are placed below the bottom of the periodic table, but these elements are otherwise called inner transition elements. And then next we are going to see advantages of a modern periodic table. So I taught about a D block. D block elements from group 3 to 12, and F block elements. F block elements are nothing but lanthanides and actinides. Lanthanides and actinides. Here it is 14 elements, here it contains 14 elements. Next we are going to see the advantages of a modern periodic table. Now we are going to see the advantages of modern periodic table. The arrangement of elements in the periodic table is based on more fundamental property. The arrangement of elements in the periodic table is based on more fundamental property, that is atomic number, and then it correlates a position of the element with its electronic configuration. It correlates the position of the element with its electronic configuration and the completion of each period. The completion of each period. These are periods. This is first period, this is second period, this is third period, this is fourth period, this is fifth period, this is sixth period, this is seventh period. So the completion of each period is logical. And then periods, the elements in the periods are arranged in the increasing order of atomic number. The elements in the periods, let us see, lithium, the atomic number is 3. For the element beryllium, the atomic number is 4. For boron it is 5, carbon it is 6. So, the elements in a period is arranged in the increasing order of a atomic number. Atomic number is nothing but number of electrons. So, how the electrons are arranged in the subshells. So, period, the elements in the period are arranged in the increasing order of atomic number. The electrons are filled in the increasing order of energy. So, the electrons are gradually filled up in suborbitals, and finally it reaches the electronic configuration end up with, in each period it is end up with inert gas configuration. So, in a period the elements are arranged in the increasing order of atomic number. So, the electrons are gradually filled up in orbitals till it reaches the inert gas configuration, and then each group is independent. Each group is getting independent property. So, idea of subgroups are discarded, and only one question is given for all the isotopes. For example, hydrogen contains 3 isotopes: protium, deuterium, tritium. It contains 3 isotopes, but it is not given separate places for all the isotopes. So, only one position is given for all the isotopes, because all the isotopes contains the same atomic number. So, only one position is given for all the isotopes. And then the place for placing the 8th group, justification is given, and the elements from 3 to 12, the elements in the group from 3 to 12, their property is intermediate between non-metals and metals. These are the elements getting the property intermediate between the left portion and the right portion, and then it separates the metals from non-metals. The periodic table separates metals from non-metals, and earlier in Mendeleev's period, the elements which was misfit in periodic table is placed properly in modern periodic table. Justification had been given for placing the elements in the position, and then justification was made for placing the lanthanides and actinides, because their property is entirely different from the elements in the main periodic table. So, justification was made for placing lanthanides and actinides at the bottom of the periodic table. These are the advantages of modern periodic table. Once again, I am going to recollect. It is based on more fundamental property, that is atomic number, and it correlates the position of the elements with its electronic configuration, and completion of each period is logical. Elements in the period are arranged in the increasing order of atomic number. So, the electrons will be gradually filled up in orbitals, and finally it end up with the inert gas configuration, and each group is independent. So, idea of subgroup is discarded. One question is given for all the isotopes. Only one question is given for all the isotopes, because the elements are arranged in the increasing order of atomic number, and justification was made for placing the 8th group elements in the periodic table, because group 3 to 12 are called transition elements. Why these are called transition elements means their properties are intermediate. These elements properties are intermediate between these elements and these elements, and then it separate places. It gives separate places for metals and non-metals. Some of the elements which was misfit in Mendeleev's periodic table was placed in proper place in modern periodic table. Justification was given for that, and then placing the lanthanides and actinides at the bottom of the periodic table, justification was made. The elements in the periodic table was broadly classified into three categories. One is metals, second one is non-metals, and third one is metalloids. We are going to analyze the position of each one. First, we are going to analyze the position of hydrogen. Though hydrogen is gas, it is placed along with the metals. Because why it is placed with the metals? Alkali metals means hydrogen is capable of losing one electron like metals. Metals are capable of losing one or two electrons. Hydrogen is capable of losing one electron. When it is losing one electron, hydrogen, when it is losing one electron, it forms hydrogen ion. It forms hydrogen ion. So, hydrogen is capable of losing one electron to form hydrogen ion like metals. Metals are capable of losing electrons. So, because of this property, because of its electron losing property, it is placed with the metals. At the same time, hydrogen is capable of gaining electron too. Hydrogen is capable of gaining one electron too to form hydride ion like halogens. This is like metals. So, hydrogen is capable of losing one electron like metals, so it is placed along with the metals. It is capable of gaining one electron, so it is capable of forming hydride ion, so it is getting the property of halogens also, and then it is a diatomic molecule. Hydrogen is a diatomic molecule like halogens. Halogens are diatomic molecules. So, proper position is not given for hydrogen. The position of hydrogen is still under debate because its property is coinciding with the metals as well as its property is coinciding with the halogens also. So, that should be placed in between, but it is placed along with the metals since it is capable of losing electrons like metals. So, it is placed along with metal, but the position of hydrogen in modern periodic table is still under debate. That is about the position of hydrogen. Next, we are going to see about position of rare gases. Group 18 elements are called rare gases. Group 18 elements are called rare gases, and otherwise they are called inert gases. Why they are called inert gases? Means they need not to gain electron or lose electron to attain stable electronic configuration because their electronic configuration is already stable. So, they need not to lose or gain electron. So, they will not react with any of the elements. That's why they are called inert gases. They are inert in nature. So, they are called inert gases since they are present only a little percentage in atmosphere. That's why it is called, because of its little percentage, very less percentage in atmosphere. It is called rare gases. It does not react with, do not react with, they do not react with other elements. So, they are inert gases. So, they are called inert gases. Because of their inactivity, they are called inert gases. Because of their less percentage in atmosphere, they are called rare gases. They are placed in the 18th group. And then next we are going to see about the position of metals. The metals are placed in D block. Most of the metals are placed in D block, and it occupies, metals occupy large area in the periodic table. Look at the periodic table. This is the area of metals. So it is occupying the larger area of the periodic table. And what are the unique features? What are the unique characters of metals? Means they are shiny, very hot, and their ductility, malleability. Ductility means drawn into wires. That means metals can be drawn into wires. That's why we are making aluminum wire and copper wire. Copper and aluminum are metals, you know. So they have ductile. Ductile means drawn into wire, and malleability means beaten into sheet. We are making metal sheets for roofing, you know. That is nothing. That is metal. They have malleable character also. So they are shiny, hard, ductility, malleability, fusible. Fusible means at ordinary temperature they will be in solid state. When it is heated at a high temperature, they will be molten into liquid state. That is called a fusible. So they are fusible in character, and then they are very good conductors of heat and electricity. Good conductors. They are good conductor of heat and electricity. These are the unique characters. These are the unique characters of metals. They are shiny, hot, ductility, malleability, malleable, ductile, fusible. They are good conductors of heat and electricity. These are the unique characters of metals, and most of the metals exist in solid state except mercury. Mercury is the only metal which is present in liquid state at room temperature. Again, the metals can be classified into 4 types. First one, alkali metal. Alkali metal is nothing but group 1. Group 1 metals are called alkali metals. And then second one, alkaline earth metal. Group 2. Group 2 elements are called alkaline earth metals. And then third one is transition metals. Transition metals are found from group 3 to 12. And then the last one is P block metals. As I already told you, the P block is a home of variety of elements. This contains metals, non-metals and metalloids. Here aluminium, gallium, indium, thallium, tin, lead. These are the metals. They are placed in the P block. So these elements are called P block metals. Which are P block metals? Aluminium, gallium, indium, thallium, lead, and then tin. These are placed along with the P block elements. So these metals are called P block metals. And next we are going to see about metalloids. Metalloids means the elements which have the property of metals as well as non-metals. They are called metalloids. The elements which contains the property of a metal as well as non-metals. They are called metalloids. Their property is intermediate between metals and non-metals. Those elements are called metalloids. Here arsenic, selenium, tellurium, silicon, these are antimony, bismuth, arsenic, antimony, bismuth, these are metalloids. These are metalloids, arsenic and antimony. These are called, this is example. Example for metalloids are arsenic and antimony. These are the elements which have the property of metals and non-metals. That means sometimes they will be getting the property of metals, sometimes they will be getting the property of non-metals. So their property is intermediate between metals and non-metals. So they are called metalloids. These also placed in p block elements, along with the p block elements. And next we are going to see about non-metals. Non-metals are the elements, their property is entirely different from metals. Already I told what are the properties of metals. Properties of metals are shiny, hot, ductile, malleable, fusible, and they are the good conductors of heat and electricity. These are the unique properties of metals I told. The elements which do not possess the properties of unique properties of metals are called non-metals. Non-metals are boron, carbon, nitrogen, oxygen, halogens. These are called non-metals, and these also non-metals also placed in the p block elements. So non-metals are placed in p block, and metalloids also placed in p block. Some of the metals also placed in p block. Those metals are called p block metals. Example: aluminum, gallium, indium, thallium, lead, tin. These are the metals. They are placed in p block. So they are called p block metals. And non-metals are placed in p block, and metalloids are placed in p block. The non-metals will occupy the upper right corner of the periodic table. Upper right corner of the periodic table contains non-metals. And next we are going to see about alloys. In 3500 BC, people used alloys. People used alloys in the form of bronze. Bronze is an alloy of copper and tin. It is alloy contains two elements, copper and tin. So it is a mixture of metals. So alloys are the homogeneous mixture of metals. Mixture of metals with non-metal also we can say alloy. So alloy is nothing but a homogeneous mixture of metal with metal or metals with non-metals. That is called alloys. So alloys were used before Christ. That means 3500 BC itself alloys were used by the people. Bronze is the alloy used by the people. So the people in olden days people knew about making alloys. And what are the properties of alloys? Now alloys plays vital role in our day-to-day life. The stainless steel that we are using is nothing but alloy, and the ornamental gold The gold ornaments we are wearing, that is nothing but alloy. That is a mixture of gold with copper, and stainless steel is also an alloy. So what are the characteristics of alloys? That means the properties of alloys. Alloys are the mixtures of a metal with metal or metal with non-metal. First one, it is not easily corroded. Alloys are not easily corroded. That means it is not affected by acids or any other substance. So that is called it is not easily corroded. Or corroded to a very less extent. It is not easily corroded, but in case if it is corroded means only a little extent. That is the first property, and alloys are stronger than the respective metals. For example, the pure gold is not good for making ornament. Why it is not good for making ornament means the pure gold, if we make ornaments with pure gold, we cannot make anything because it is brittle. When we are making the ornaments with pure gold, it will be brittle. When it is mixed with copper, that means the ornamental gold, that is stronger than gold. That is so the alloy, ornamental gold is an alloy that is stronger than pure gold and copper. So that is the second property. And the third property, alloys are non-conductors of heat and electricity. They are non-conductors. They will not conduct heat and electricity, or little extent. They will conduct heat and electricity to a little extent. So it is not easily corroded. It is stronger than respective metals. For example, ornamental gold is stronger than gold and copper, and they are non-conductors of heat and electricity, or they will conduct heat and electricity to a little extent, and then their melting point is very low. Melting and boiling points are very low. Lower than the respective metals. So these are the properties of alloys. Once again, alloys are nothing but a homogeneous mixture of metal with metal or metal with non-metal. Second property, alloys are not easily corroded or corroded to a little extent, and it is stronger than the respective metals, and it is not a conductor of it is non-conductor of heat and electricity, or it will conduct the heat and electricity to a little extent, and its melting point is lower than the respective metals, and the boiling points also lower than the respective metals. So these are the properties of alloys. Now I am going to recollect the things. What are the things I have taught you in this class? First, I taught about the features of modern periodic table. And then advantages of, first I taught about the features of modern periodic table, second I taught advantages of modern periodic table, and then how the elements are classified as groups and periods. And how we classified the elements in blocks, that means S block, P block, D block and F block. How we arrange the elements in S block, P block, D block and F block. So classification of elements in blocks, that also we had seen. And then we had seen about position of hydrogen, and we had seen about the position of metals, and we had seen about position of non-metals, and position of metalloids, and then alloys and their property. So these are the things we have discussed in this class. Thank you, students. Stay home, be safe.